You may find that you're asked to explain the nature of metallic bonds. We would describe it as an electrostatic attraction between a lattice of cations and delocalized electrons. This would be an example of perhaps a group 1 metal, where each positive ion would form a positive 1 charge and would include one delocalized electron. What makes this an attractive force is this positive 1 ion is attracted to other atoms' electrons too. And similarly, this positive 1 ion is attracted to these electrons as well. And so we have these positive charges being attracted to the same electrons, and thus these positive ions inadvertently hold on to each other as well. And the more delocalized electrons there are, the stronger that attraction will be. The properties of a metal that have to do with it being bendable or ductile have to do with this fact that these electrons are free to move, thus the bond isn't really fixed in one spot. The strength of the metallic bond is going to depend on two things. One, the charge of the cation and the number of delocalized electrons. Let me show you an example here. Sodium has a positive 1 charge and would have 1 delocalized electron. Magnesium has a positive 2, and each cation will have 2 delocalized electrons. Aluminum plus 3. So we would expect that as we go from sodium to potassium to aluminum, that this strength of the attraction will increase. Because of this change of going from a plus 1 attracted to a minus 1 to a plus 3 attracted to 3 electrons. The second thing that matters is the size of the ions, because the size of the ions is going to give us information about how far apart are these positive and negative charges. If they are smaller, that is, they can get closer together, it's going to give us a stronger attractive force. And if we have a stronger force of attraction, that will be reflected in a higher melting point. So when we learned about our melting point trends for metals, let's say we're considering group 1. We're going from lithium to sodium to potassium, rubidium, cesium, and francium. Now, as we go down the periodic table, we're going to find that the size of the ion increases. And since the size of that ion increases, the strength of the attraction will decrease. So instead, melting point for group 2s, or for group 1s and group 2s, is higher at the top because we have smaller ions. We learned this trend for group 1 and group 2 metals. If I was comparing across a row, the size of the ions would matter in addition to the charges. So when I said there's a stronger attraction because there's a plus 3 and a minus 3, there's also a stronger attraction because these are smaller ions and these are larger ions. And that has to do with the effect of nuclear charge and how hard those protons are pulling on those electrons. So you will be asked to explain which one has a higher melting point and why.